Okay, so let's get started. We're going to be taking a look at how to set up our main rev limiter programming found in our Link G5 and G4X systems. Now, our main rev limiter programming will be obviously allowing the main rev limiter to function. This is in place so we don't over rev the engine as we're coming up to very high engine speeds. If we want to rev the engine to 7,500, we'll put our limiter at 7,500. We don't want to go above that. We can mechanically over rev our engine very easily, so the limiter is in place to either cut fuel or spark timing to prevent an overrun of where we want the engine to actually operate at in terms of engine speed. Now, in addition to understanding how to program the limiter, that's pretty easy. There is advanced cut strategies here in the software that I want to dig into and model with the engine simulator here so you can see how they actually work, because it's easy to get lost in some of the settings. If you can see things slowed down, you can decide how you want that limiter to be placed on the engine that you're calibrating and tuning, and it gives you a lot more control rather than using the standardized limiter that they have, the default limiter settings that they have in place. So you may want to go and experiment with doing some advanced setup. We're going to take a look at that. Now we're going to move from our basics page right here, and then we're going to jump across under a page labeled safety. Now in here, we have a lot of programming and logging that we can take a look at here, time plot, parameters list, and all of our tables that we can program in the window here. What we're interested in right now is just focusing on our RPM limit table 1 and 2. We'll talk about why there's two tables here in a little bit. Specifically, we're going to learn how to set up our RPM limit table 1. That's generally all we need in order to provide a proper limiter for the engine that you're tuning. We do have other options here. We have map limit tables, also known as boost cut, and general purpose tables. These general purpose tables can be used for things like oil pressure protection or lean protection. So they're very, very useful in fail-safe strategies. We'll take a look at setting up the fail-safe strategies. And the next training module, again, we're focused just on setting up our main rev limiter and understanding all of the cut strategies that are involved. So what we're going to do is go up to our RPM limit mode, and this is going to be where we choose whether we're going to have an ignition cut, a fuel cut, or we want to disable the limiter altogether. Now, let's talk about the differences here between ignition and fuel cut. If you have a normal engine that's running on petrol fuel and you want to go ahead and shut down the engine, you want to limit combustion, you can do that in two ways. We can do ignition or fuel cut. Both will work just fine. Some engines, such as an SR20 engine, really should not have an ignition cut limiter. Ignition cut limiters are a little bit more aggressive of a limiter compared to a fuel cut. The advantages of a fuel cut, it's a softer type of limiter generally, but a lot of people worry that you're going to get a lean condition when you shut the injector down. Technically speaking, that is something to be concerned about if it's a high boost type of environment. But I have not had an engine using a fuel cut that's failed and leaned out as a result of the fuel cut. Just for perspective's sake, I've done a ton of engines tuning with Link. My biggest deciding factor when I'm choosing whether it's going to be a fuel or ignition cut is what engine am I tuning, and then what type of fuel that I'm tuning on. I mentioned petrol fuel just about a minute ago. If I'm tuning on a methanol, nitromethane fuel in my engine, that requires a ton of fuel flow being pumped through the engine, especially if it's turbocharged. You're going to find you probably want to use a fuel cut. The reason why you'd want to use a fuel cut is if you're only cutting spark and not fuel, and you're on a limiter, that can be problematic because you're going to load the fuel up into the cylinder with that huge amount of fuel flow coming into the engine. You're going to load it up and you could potentially hydrolock the engine in some situations. So a fuel cut works better for methanol or nitromethane engines, specifically if you're running that fuel type. Ignition cut, though, is my general choice for most turbocharged engines that are running petrol or even ethanol fuel. Usually it's not so much of a concern on ethanol, even though we are having a little bit more fuel flow through the engine if we're going in and just cutting our spark and letting that fuel pump through. So that's kind of my deciding factor. Now, then also comes down to what specific type of engine that I'm tuning. Some engines, specifically SR20 engines, are super sensitive to the limiter type. If you choose ignition cut, you almost always will float a valve or have a rocker problem on those engines. I'd recommend, especially with drifting with an SR20 engine, select fuel cut. For a basic street application that just needs a basic limiter, fuel cut works fine. If you're trying to build a lot of boost on anti-lag, if you're trying to get a more of aggressive sounding limiter, ignition cut's when you choose, but then also comes down to that fuel type that you're running. So you have to choose what you're going to work with here. I'm going to use fuel cut for a basic rev limiter because that's what we're really focused on in this training module. Let's click OK here. And then It's going to ask if I want to go clear out the table. We'll click yes. We see the RPM limiter table 1 here appears. This is our main rev limiter table. Let's talk about this first. We can go in here. We do see there's a dual table option that's off, advanced mode that's off. We'll talk about advanced mode here a little bit. Let's go into the table here and actually configure it so it's useful for a main rev limiter. We can find the table right now is based on gear. It's also based on engine coolant temperature. Now, if we want to set up a rev limiter based on gear, we can do that in here, but let's assume that we just want to keep things simple and we just want this based on engine coolant temperature. What this does is provide us 2 different aspects for a rev limiter built into one table. First, it's going to take into account where we want to have the maximum RPM to spin the engine to. Let's assume I'm only spinning the engine to, let's say, 8,000 RPM. That's going to be where I put my limiter. That's usually going to be 500 RPMs from the highest point I make peak power at. Other considerations are going to be mechanical strength of the engine. So if you don't have an upgraded valve train in the cylinder head, you don't have upgraded pistons and rods, the engine mechanically can't take the higher RPM, well then you can't raise the rev limiter past stock limiter. So if your stock limiter is at 7,000, you have a stock engine, you're not going to really get a whole lot going beyond that. Mechanically, you're not going to be able to do it because the engine will fail. General kind of rule of thumb with rev limiters, on a stock engine, you can usually go 200 to 300 RPMs higher than a factory limiter safely. I don't go past that. So if I have a factory limiter, factory engine, 7,000 RPM, I won't go much past 72, even if the engine's making power beyond that. There is a mechanical aspect of this that we have to be mindful of when we're putting a limiter. We don't want to rev past an unsafe point. So things you have to take into account: where do you want to spin the engine to? Where is it logically safe to spin the engine to? And that's what we're going to program in here. But because the table is based on engine coolant temperature, we can take this a step further and actually set this up as a fail-safe strategy so that if the engine starts to overheat, we can have a lower limiter in place, essentially an overheating limiter. Let's learn how we can build this out. So if we click in,
thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.